Awesome. Herman the Hermit Crab. He approves. So we're going to touch base pretty quickly. I don't want to go through every single math equation and balance for x, every single one. We've already actually done this for doing 3 or more feed resources. At this point of me talking right here is when I would generally say, how do we do a Pearson square if we have 3 or more resources? Our Pearson squares and our solve for x's and y's, right? Actually, both of those things are, there's only two. Pearson square, there's only one thing here, one thing here. What happens when we get to 3? I'd bet dollars to pesos that right now, which would be right after I would ask that question, I'd be hearing crickets in class, maybe. Right? Oh, I don't know. You all know exactly how to do this. We also can do it algebraically, and we can also do it by the Pearson square. We'll generally do it by the Pearson square because we can do it on the back of an envelope very quickly. So, like I said, I don't want to do every single one here and take up everybody's time. What we do is start with our big picture, right? And take our first 2 ingredients and blend them and balance them for our first goal of the nutrient requirements, okay? And then that mix is going to be one out of the then 2 components, okay? We do a little staging area. So essentially, actually, to balance with 3 or more feedstuffs, we essentially just do the Pearson square twice, okay? So you have these as a resources to look over. Prepare 100 pounds diet containing 12% protein from soybean meal at 44% crude protein and tankage at 60% CP. So this mixture is already mixed, okay? Very easy, actually. I would much rather you also have to do this one, right? Say, for instance, balance your soybean meal and tankage for energy, for instance, okay? And then go from there. But that's already done, okay? So we already have how much of each we have. 3 parts soybean meal and 1 part tankage, okay? 75% soybean meal, 25% tankage. And then we're going to mix those with our corn, which is 9%. So everybody, please remember, if you don't remember, you'll figure it out as soon as you start Pearson square, that right, your goal number needs to be intermediate between your 2 classes of feed things, or between your mix, which is already 2 feedstuffs, and then your next one, or your mix and your mix, whatever it's going to be. Your goal needs to be between them, right? Because you're balancing, okay? Could we balance a mixture of soybean meal? Could we balance soybean meal at 44% crude protein and tankage at 60% to get 12% protein? No, obviously not. Of course not. Never. Not within the realm of thermodynamics and mathematics, right? Because we're already over the threshold. We can't dilute it, right, with equally strong stuff, okay? But our corn is a low ball, okay? And so hopefully also you all are being judicious, right, when looking through these formulations. So, you know, we have our mathematical checks, okay, where we can go back and add up our parts to get what our total target part would be out of 100 pounds, for instance, okay? But then we also just have our common sense as we're moving through this and along this. We also have our common sense thoughts of what this is going to be. So we have a goal here at 12% protein, and our corn's at 9, and our soybean meal mix has 44% crude protein from the soybean meal and 60% protein from the tankage. So hopefully it's already pretty fairly clear that this mixture is going to end up being more of a supplement, right? You're going to end up using, the base of this ration is going to be corn, okay? And only a small amount is going to be from the soybean meal and tankage, because the soybean meal and tankage is so much higher, so much more than 12%, right? Or our corn is closer to there, right? So we're not going to need very much soybean meal and tankage mix to get that number from 9 to 12, okay? All right, so we get our weighted average of crude protein for ingredients that are similar, right? So the things that we're first starting with, for this instance, soybean meal and tankage. So it would already said in our setup here, they have 3 parts soybean meal to 1 part tankage. 1 part tankage, 1.92 part CP from our mixture. 1.92 part CP divided by the 4 parts of the total mix, okay, right? It was 48% crude protein. Again, ought to make pretty good sense just as we move along before we mathematically check it, just to think that, oh, it's 3/4, 44%, only 1/4, 60, so we're really not going to be too much higher than 44, okay? For that mental check is handy right here, because if you were to, do something wrong in the math here and your number comes out to 58, okay, you'd want to be able to identify and be judicious and look at your numbers and think, does that make sense? Hopefully, excuse me, hopefully your math skills are just going to be such that you won't have to just do the quick line mental check, but you can just know with great assurance that you have done it well, right? Okay, also our Pearson square. Start with our corn is what we know, okay? Our 12% is what we know, it's our goal. And we have our mix that we just formulated just in the last slide. So again, that would have been, for context, when we did some of these other things and balanced for 3 items, that would have been our initial balance, and then our mix is what goes in here in the Pearson square, okay? And so our mix is going to have a crude protein that's intermediate of the crude protein of the 2 ingredients of the mix, okay? And it's going to result in an end percent of crude protein, whatever that is. And then we can just do a quick Pearson square for our mix, which is 2 feedstuffs, and our third one, right? So 3 feedstuffs. And then, right, since Pearson square gives you a percentage, we want to eventually get that back into our pounds so we can physically create our formulation, right? 92.31 pounds corn and about 8 pounds of mixture. So, excuse me. Oh wow, my little mental note about a few minutes ago proved to be kind of handy here, right? Again, your corn was much closer to your target than the other mix was. So it ought to be pretty clear as you're moving. Corn is going to be the majority of your diet. Still want to mathematically check. And then also keep in mind that if you were making this from the ground up, okay, that your 7.69 pounds of your mixture, you're still going to have to make that mixture, okay? So you're still going to need to know what the percentages of each of those components of the mixture are in order to make it, okay? The rubber's got to hit the road, okay? Check. Our goal is 12 pounds. We add up all components, and and we've got a match. Algebraically, we can do this in a similar way. This is what I do not want to spend a whole lot of time in, especially on these shorter videos. But I do want to get here. Sorry, my computer keeps going to sleep. I can't see myself. Oh, there it is. All right. So, quick exercise just to make sure that you guys are still can still do this. Please email me this. Actually, I take that back. Could you please put this on La Lima? I will create a discussion forum for this talk, and then if everybody could put their responses up on La Lima, that would be really great. Formulate 1,500 pounds of 15% crude protein sow lactation diet using a mixture of 3 parts ground corn, add a 9% crude protein, and 1 part oats, 11% crude protein, in conjunction with soybean meal, which is 46%. Okay? Determine the amounts of corn and soybean meal needed to meet the daily requirement of crude protein and metabolizable energy for a 27.3 kilogram pig using corn and soybean meal. How many kilograms of corn and soybean meal, respectively, do we need? Here's a lot of very helpful information, okay? I need essentially 10% crude protein, right. Our metabolizable energy, that's per kilogram, okay? Then we have our nutrient contents, okay? And you don't even have to change them from kilocalories per pound to kilocalories per kilogram, do you? It's amazing, okay? Easy algebraically. Algebraically, we can do it, no problem. Please use this as a reference. Check. Yes. But for y'all, I want you to do a little Pearson square of that, please, for me. I really would appreciate it. Okay, so just to recap, it can only be used for 2 to 3 materials, but they can always be mixtures, so you can do it ad infinitum, right? As much as you can. Number in the center of the square, the Pearson squares must be intermediate to the numbers of your inputs, right? And then the requirement also has to be expressed as a percent or proportion that can be used for any nutrient or expression of energy, okay? Just like the kilocalories per kilogram or pound, right? Same thing, it works. Acceptance of linear programming and the formulation of least cost diets for livestock and poultry feeds has been extremely rapid and is becoming almost universal in its usage in the feed industry. We could probably take that almost out, guaranteed. Outside of more backyard farms, most, if not the majority of producers, are going to be using software, which just many of the software programs are actually hooked up to the feed bunkers, right? So they can automatically mix whatever. You don't even have to tell it the number that you want it to mix to. You can just have your animal's ear tag, and it'll record. You can have your recorded weights on there, and then it'll adjust accordingly based on all the nutrient requirement data that is stocked up and available online. Mathematical technique for determining the optimum allocation of resources to attain a particular objective, right, is what linear programming is. And so that can also be, you can also run economics, which it would behoove you very much to do, right? To include economics in that factoring to then result you in the most economical options, okay?
For the computer to formulate a diet, we need the feed ingredients that are going in and their cost, right? The economic component, of course. Nutrient content of each ingredient, nutrient requirements of the animal, and some of those are more precise than others in the programming. And physical, non-nutritive, nutritive usage limitations on certain ingredients, i.e. some are palatable, they can't be present in a large percent. We mentioned that things like blood meal, things are generally most effective when they're less than 3% of a total ration. Okay, you guys, I'm going to set that up on Laulima, and we will go from there. Mahalo, aloha.